Okay, so a little bit of a warm-up here. What I'd like for you maybe to do is to solve this problem using synthetic division, and pause the video, try and solve it, watch the video, and see what your solution is and make sure it matches mine. So when I say solve, one of the things that we need to keep in mind is I want to find x. And these are polynomial functions, so I'm still finding x-intercepts, or what are called zeros, and which are sometimes called roots. Okay? So this is what we're solving. And we're going to fall into this with the rest of section 7.4 is kind of built off this principle. Now this one, because it's a cubic and we're pulling out a linear term, we're going to be left with a quadratic. We know how to solve quadratics. So the idea is cubics, if we look at the different types of factoring methods, this one we wouldn't be able to factor using the methods that we know by hand. So I'm telling you to divide out the x plus 1. Because I'm telling you to solve, it should work. We should see a remainder of 0. So the first thing that we do is we take this guy, x plus 1, we set it equal to 0, and we solve. So we know one of the zeros is negative 1. So we're going to go ahead and list all our coefficients, 1, 6, 4, negative 1. Drop the 1. 1 times negative 1 is negative 1. Gives me a 5. 1 negative 1 times negative 5 is negative 5. Add these guys, we get negative 1. And gives me a positive 1. So this guy, what's left over, is x squared plus 5x minus 1. Now I need to solve, so I have to solve this guy. Well, this guy is not factorable, so I have to use the quadratic formula. And so I'm going to go ahead and plug in all my pieces. B squared is 25 minus 4 times A times C, all divided by 2A. So now I'm going to go ahead and simplify what's in my radical. And that's going to be a 25 plus 4 all over 2. And so I'm left with negative 5 plus or minus the square root of 29 all over 2. And from the beginning of the problem, I also had that negative 1. So my x's are equal to negative 5 plus or minus root 29 over 2 and the negative 1. So I used synthetic division to break it down into a quadratic, and then from there I had to use the quadratic formula to find the other x's. If it's factorable, you factor it. If not, you have to use the quadratic formula. And so when we say solve using synthetic division, not only do you need to find the quotient from synthetic division, but now you need to take this guy and factor it further to find our solutions.